Hello everyone, today I'm going to be going through asynchronous T flip-flop counters. Now these are actually simpler than the D-type flip-flops and they essentially work in the same way. So a D-type, I'm just going to go over something very quickly. A D-type flip-flop in this configuration this is essentially the same as that. Now I should have really specified this, but this lesson is actually simpler than the D-type one I just explained. But once you get this, you'll find it easier to understand the D-type flip-flops a bit more. But they act the same, and except that in a D-type synchronous counter, in a T-type asynchronous counter, your Q goes to the next stage in an up counter, and in a D-type version, the Q bar goes to the next stage, to the clock of the next stage. But I'll go into that with the T-types in a moment. So let's get started with this circuit. So we have our clock signal, and remember we've got our rising edges, which I've marked. Always mark the rising edges, it makes it a lot easier to draw these timing diagrams. Now T is 1. It's always 1 because you've tied it to 5 volts, which is essentially logic 1. So there's a 1 always here. And if you didn't watch my latches and flip-flop video, then you wouldn't know this, but when T is 1, the outputs will flip-flop. So on a rising edge, this will become 1, this becomes 0, and it will keep doing that on every rising edge of the clock. So that's, put it simply. And that, with that information, we can now draw the timing diagrams. So we want to draw Q. We don't really care about Q bar in this circuit, it doesn't really matter. So Q on the, let's say it starts at 0, because we're going to be trying to count up, so starting at 0 is always good. So on the rising edge, Q toggles, and on the second rising edge it toggles again, and it just toggles. So that has this out the way. I'm going to annotate this as Q1. This is our first flip-flop. So let's copy this. And I'm going to remove this. Remove that. And that's going to be our Q2. I'm going to move this closer. That'll do. Okay, I'm just going to draw an X there because we're not bothered with what Q is. This just means that it's not connected to anything. So let's connect Q1 to the clock of the next T flip-flop. And since the second flip-flop is going to act on the rising edge of the clock of Q1, it's going to act on the rising edge of Q1. So I'm going to mark all the rising edges of Q1. So this is here. That's 1 and that's 1. You see there. So now we can draw the waveform. If we're assuming Q2 starts at 0, then that is going to go that way, and then it's going to toggle there. So I think we've just made a down counter. So let's verify this. So each one of these is one of our clock pulses. So I'm going to draw a table very quickly. So on our 0th clock pulse, both of these are 0. On our first clock pulse, both of them become 1. On our second clock pulse, Q1 it goes to 0 and Q2 stays at 1. On our third clock pulse, Q1 goes to 1 and Q2 goes to 0. And on our fourth clock pulse, both of them are at 0. Now this is, you can see that it's starting at 0, then it's going to, and then it's counting down in binary, which is not what we want. So let's try, if we put a NOT gate here, let's see if this works. So now we have a NOT gate here. This means that, well, this is going to be our, this isn't technically going to be our clock. This is going to be this input here. This is going to be that. So if we were to send it through the NOT gate, the actual Q will, the actual clock will be the opposite. It will be like that. And you can see all of the rising edges are on the falling edge of these ones. Yeah, so all the rising edges act on the falling edges. So we don't actually have to redraw this graph, this timing diagram. What we can do is, if I just rub all this out, since all of the rising edges on this clock are going to be the inverse of this wave, we can just mark the falling edges on here, and since we also want a NOT gate here, instead of actually using a NOT gate, we can just use Q bar, can't we? Because Q bar is the opposite of Q. It's not Q, isn't it? Q bar is not Q. So Q bar goes to clock, and we don't care about Q. Or Q is our output. And let's just go. So let's mark up what this circuit is going to do. So on Q1, it's, let's say they're both starting at 0. Q1 is going to change on the falling edge. It's going to flip-flop on the, it's going to toggle on the falling edge on this one, and this one, and this one. Q2 is going to toggle on all the falling edges of Q1, and this is because Q bar 1 is going to look like this. It's going to be the opposite of Q1. And since Q bar 1 is connected to the clock of the second flip-flop, Q2 is going to change on the rising edge of all of the clock. It's going to toggle, isn't it? So if we marked the rising edges on here, that would be the falling edges on Q1. You can see they're in the same, at the same time. So let's mark those on. So now we can draw our timing. So let's verify to see that it's actually counting up. We can see let's mark the pulses 1, 2, or the falling edges, sorry, 4, but that's essentially our pulse. Because don't forget, the actual clock is going to be the opposite of this. It's going to be like that, and we'd be doing it on the rising edge of that, because you know it's the knot of this. This is that. So on the 0 pulse, we can see that Q1 is 0, Q2 is 0. On the first falling edge, we can see that Q1 is 1 and Q2 remains 0. So on the second pulse, we can see that Q1 is 0 and Q2 becomes 1. On the third pulse, we can see that Q1 becomes 1 and Q2 remains 1. And then on the fourth falling edge, we can see that both of them become 0. So now we can see that it is counting up like the other circuit. I'm going to leave that there because it's going to be quite a long video, this one, I think. And I know these timing diagrams become confusing, but you just got to think about it when you're doing them. It may take time, but you do have to think about it. And if you're not getting the result you want, you just need to change and just see whether this will work. You've got to work out whether what you've changed will help and get what you want out of the circuit. Oh, this would be Q1 and Q2. So that would be your T flip-flop up counter, which is asynchronous, because like I said in the last video, asynchronous would be the two clocks are connected together to a common clock, whereas in asynchronous, the clock is connected, of one stage is connected to something else on the other stage. So yeah, I am going to leave it here. Thank you for watching. If there are any questions, just put them in the comments.